Hello student, today we are going to start the triple integration. It is the extension of double integration. Means if we know how to decide the limits of double integration, then it is the easy part. Only extension of one variable, that is supposed to be z here. So if integration I equal to triple integration of f of x, y, z, dx, dy, dz, then we want to find first the limits of z. For example, here the figure and here limits from this point to this point we have to find. So always you find the limits of z along z axis. So this is the z axis and integrate, and then it will be in double integration. And once it is in the double integration, then easily we can evaluate it by using the double integration theory part. What are the limits of z? You decide first. So here this inner integral will becomes like this. Integration from z1 to z2, f of x, y, z. So these are the limits of z. So integrate with respect to z first. So whatever the result will be in double integration. Then we should know how to evaluate double integration. Sometimes this triple integration we have to convert into cylindrical coordinate system or spherical coordinate system. So what is it? So cylindrical coordinate system rho phi z. So to change the rectangular coordinate x, y, z to cylindrical coordinates rho phi z, the cylindrical transformation are x equal to rho cos phi, y equal to rho sin phi, and z equal to z. Also dx, dy, dz equal to rho d phi dz. Note that this is a phi angle with x axis. It means that only if we consider x and y. So whatever there, this is supposed to be with x axis, this is phi. So what is it? It is a p rho phi z. So suppose this is the point P. Draw a perpendicular on xy plane, and whatever the angle with x axis means what? Draw the perpendicular and join this point of perpendicular to the origin, and whatever the angle that is supposed to be phi, and by using that, this is the rho. So rho cos phi, y equal to rho sin phi. So these are supposed to be a just double integration or in a plane polar transformation. X equal to r cos theta, y equal to r sin theta. So just like that is the rho cos phi, y equal to rho sin phi. So you can convert into cylindrical coordinate system. Normally I am using a spherical coordinate system. So what is it? Very interesting. Note that here. Spherical coordinate system r theta phi. To change rectangular coordinates x, y, z to spherical coordinates r theta phi, the spherical transformations are x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. Then definitely dx, dy, dz equal to r square sin theta dr d theta d phi. So note that here if P is any point x, y, z, I will draw the perpendicular. So M is the perpendicular point, and if we join with origin, so I am getting this supposed to be OM. So this phi is the angle with x axis, this theta is angle with the z axis, and from this origin to that point, that is your R. Note that you always remember for a sphere, hemisphere or positive octant of a sphere, you always remember the limits. So directly you can consider. So for a complete sphere, x square plus y square plus z square equal to a square, then limits are theta equal to 0 to pi, phi equal to 0 to 2 pi, and r equal to 0 to a. For a hemisphere, if we cut by xy plane, then x square plus y square plus z square equal to a square, and z is greater than 0. It means that if we consider x, y, z, this axis x, y, z, and whatever the sphere cut by this one, so I am getting like this. So then the limits are theta equal to 0 to pi by 2, because theta is always angle with z axis. So here 0 to pi by 2. Pi is 0 to 2 pi means whole circle here, and r equal to 0 to a means radius. Radius will not change. For positive octant of a sphere, x square plus y square plus z square equal to a square, and x is greater than 0, y is greater than 0, z is greater than 0. It means that only in supposed to be x is greater than, y is greater than, and z is greater than 0, all 0. So theta is 0 to pi by 2, and also phi is with x axis only 0 to pi by 2, and r is radius will not change because it is a sphere and radius is 0 to a. So these are the limits you remember. But if ellipsoid there, x square by a square plus y square by b square plus z square by c square equal to 1, then you remember these are the spherical polar coordinate x, y, z changes to r theta phi as x equal to ar sin theta cos phi, y equal to br sin theta sin phi, and z equal to CR cos theta. It means that here A, B, C is additional, and therefore x square by a square plus y square by b square plus z square by c square equal to r square, and here dx dy dz equal to ABC r square sin theta dr d theta d phi. Standard limit 0 to pi, that is theta. Phi is 0 to 2 pi and r is 0 to 1. Note that 0 to 1 because this we are adjusting here. So let's consider examples on the triple integration. Here is the example. Evaluate integration 0 to 1, middle integration y square to 1 and inner integration 0 to 1 minus x dz dx dy. So it is very clear that here the sequence is dz dx dy is given and here limits are given. In triple integration, if limits are provided, then it is a very easy example. Only we have to check the sequence. So here it is given z, then x and y, but you can decide by this. Note that here it is a triple integration. So if we consider only these two inner integrals, so it contains x and y. So definitely first integrate with respect to z. So here solution, let I equal to integration 0 to 1, integration y square to 1 and integration 0 to 1 minus x dz dx dy. Note that these integral contains x and y. So I will integrate with respect to z first. So only z inside, remaining all outside, and that is why I equal to integration 0 to 1, inner integration y square to 1 and inside only z inside 0 to 1 minus x and dz, remaining all outsides. So I am getting x dx dy outside. So what is the integration of dz? So integration is z there. So I am getting I equal to integration 0 to 1, inner integration y square to 1 and here z, lower limit 0, upper limit 1 minus x dx dy. Evaluate it. I am getting upper limit minus lower limit, and that is why I equal to integration 0 to 1, inner integration y square to 1 and 1 minus x minus 0 outside as it is. So simplify it. So I am getting I equal to integration 0 to 1, inner integration y square to 1 and here x into 1 minus x means x minus x square dx dy. Note that now it is double integration with known limits. So here inner integral contains y. It means that first integrate with respect to x. So what I am getting with respect to x? Only x inside, and that is why I am getting integration y square to 1 x minus x square into dx and this dy outside. So just like a single integral, note that from the first here I am just solving as a single integral. So here only with respect to z, whatever the answer evaluate, then only double integration. Now I am solving again just like a single integral of this with respect to x. So I equal to integration 0 to 1 and here integration of x is x square by 2 minus x square integration is x cube by 3. Lower limit y square, upper limit 1 dy as it is. Now put upper limit minus lower limit. So I am getting I equal to integration 0 to 1, upper limit 1, so 1 by 2 minus 1 by 3 minus lower limit. So y square is lower limit. So y square it will be y raised to 4 by 2 minus y square cube means y raised to 6 by 3 into dy. So what I am getting here? I equal to integration 0 to 1 and here I am getting 1 by 6 minus y raised to 4 by 2 plus y raised to 6 by 3 into dy. So now integrate with respect to y. So I am getting 1 by 6 constant into y minus 1 by 2 y raised to 5 by 5 plus 1 by 3 as it is y raised to 7 by 7. Lower limit 0, upper limit 1. So I equal to put upper limit, so I am getting 1 by 6 minus here if y is 1, so I am getting 1 by 10 plus 1 by 21 and due to lower limit it's everywhere y, that is y 0. So simplify this. I am getting I equal to, by calculator you can find this. So by calculator I am getting 4 upon 35 which is your required answer. Example, evaluate integration from minus 1 to 1, middle integration from 0 to z and inner integration from x minus z to x plus z of x plus y plus z into dx dy dz. So how to solve it? let given integral I, integration from minus 1 to 1, middle integration 0 to z, and inner integration from x minus z to x plus z, x plus y plus z, dx dy dz. Now I equal to minus 1 to 1 integration, integration 0 to z, and inner integral. Now note that here these integral, inner integral contains x and z. So definitely we have to integrate with respect to third variable y. So integrate with respect to y. So only y inside, remaining outside. So here we cannot separate this. So x plus y plus z with respect to y, and outside dx dz. Note that this integration with respect to y just like a single integration, and that is why I am getting I equal to integration from minus 1 to 1, integration from 0 to z, and here note that x plus z is a constant with respect to y. So that I can consider x plus y. Or if you want, you can write here for simplicity integration 0 to z, and here inside integration x minus z to x plus z. Here I can write x plus z together because it is a constant, plus y into dy, and outside dx dz as it is. So here I am getting I equal to integration minus 1 to 1, inner integration 0 to z, and here this x plus z constant into dy means y, plus integration of y is y square by 2, lower limit x minus z, upper limit x plus z, and here dx dz as it is. Now substitute upper limit minus lower limit. So I equal to minus 1 to 1, inner integral 0 to z, upper limit here y replaced by upper limit. So x plus z into x plus z. So I am getting x plus z whole square plus x plus z whole square by 2, minus now lower limit x plus z into x minus z. So it will be x square minus z square plus x minus z whole square by 2 into dx dz. Simplify it. So I am getting I equal to integration from minus 1 to 1, integration from 0 to z, and here x plus z it is 1, and here half means it is a 3 by 2, x plus z whole square minus x square minus minus plus z square, and minus x minus z whole square by 2. With respect to it is x and z. So inner integral contains z. It means that we have to integrate with respect to x. So how? Minus 1 to 1, inside integration 0 to z, here 3 by 2 plus z whole square minus x square plus z square minus x minus z whole square by 2 with respect to x, and outside dz as it is. So now integrate with respect to x. So what I am getting? I equal to integration from minus 1 to 1. This is a 3 by 2, and this integration with respect to x. So it is a x plus z cube by 3 minus here x cube by 3 plus z square constant with respect to x, that is by x, minus here x minus z cube by 3, already 2 there, lower limit 0, upper limit z, and this dz as it is. So put their upper limit, then minus lower limit. So z replace means upper limit replace. So x replaced by upper limit. So I am getting here x means z, z plus z, it is a 2z cube means 8z cube by 2 minus z cube by 3 plus z square into z means z cube minus z minus z, it will be 0. Now minus lower limit. Now 0, x replaced by 0. I am getting here 0 plus z cube by 2 minus 0 plus 0 because here x is 0 now, minus 0 minus z cube. So minus z cube, it is a minus, that is why plus z cube by 6. Simplify this and integrate with respect to z. So I am getting I equal to integration from minus 1 to 1, here 4z cube minus z cube by 3 plus z cube minus z square by 2 and minus z cube by 6 into dz. So simplify it. So I am getting, so I equal to integration from minus 1 to 1, and I am getting here by calculator you can find, I am getting 4z cube only into dz. Note that here z cube is odd function, so minus 1 to 1 I am getting 0, but you can evaluate it by your way. It is that z raised to 4 by 4 with respect to z minus 1 to 1. So this 4 get cancelled. So I am getting upper limit means 1 minus lower limits, it is a minus 1 raised to 4, it is a plus 1, and I am getting I equal to 0. But by using property also, this is the odd function, I am getting minus 1 to 1 or minus a to a, it is 0. Okay, this is your required answer. Example, evaluate integration from 0 to infinity, middle integration from 0 to infinity, and inner integration from 0 to infinity dx dy dz upon 1 plus x square plus y square plus z square whole square. Note that this example is difficult by direct method, but if we convert into spherical polar coordinates, it will be very easy. How? So what are the spherical polar coordinates? First you consider the given. Let I equal to integration from 0 to infinity, middle integration 0 to infinity, and inner integration 0 to infinity dx dy dz. Note that all integration limits are constant. So given sequence is your sequence. It means that here dx dy dz. So first limits, these are the limits of x, then y, then z. Here whole square. So convert into spherical polar coordinates. So how I am getting here? It is easy by convert into spherical polar coordinate, because this term, normally x square plus y square term in double integration and x square plus y square plus z square term in triple integration, we have to convert into this spherical polar or polar coordinates. So convert into spherical polar coordinates r theta phi. As we know, x equal to, so very easy to remember this one. Note that x, then y, and then we have to write z. So here z equal to r cos theta, and here these are the r sin theta, here also r sin theta. Then you write here cos phi and sin phi, and then dx dy dz, that is equal to r square sin theta into dr d theta d phi. So note these transformations into spherical polar coordinates. So here figure from x varies from 0 to infinity, y varies from 0 to infinity, and z also varies from 0 to infinity. So what type of this thing? You consider here x axis, y axis and z axis. So here x axis, y axis and z axis. So here x axis, here y axis and here z axis. Z from 0 to infinity, note that this is infinity. Y also from 0 to infinity, and z also from 0 to infinity. It means that whole first octant is our region of integration. And now we are going to convert into polar. So in polar, what is a theta? Note that if supposed to be any p x y z, if we draw the perpendicular and if we join this, and also if we join this line, so I am getting this is r. So this radius from 0 to, what is our last point here, in up to infinity. So r is very clear that 0 to infinity. What about theta? It is in first quadrant, and that is why here theta with z axis means it is only 0 to pi by 2. And what about phi, this angle? It is only here possible, that is also 0 to pi by 2. And therefore I can write here limits are 0 to infinity, theta 0 to pi by 2, and phi 0 to pi by 2. And now substitute this substitution in given integration. So I am getting I equal to integration 0 to infinity, inner integration 0 to pi by 2 and 0 to pi by 2. Now here dx dy dz, so it will be r square sin theta dr d theta d phi upon 1 plus, so x square plus y square plus z square, it is r square. So 1 plus r square whole square. So inner integral, note that these are the r theta and this is the phi. So first integrate with respect to phi, remaining all outside. So I am getting I equal to integration 0 to infinity, inner integration 0 to pi by 2, only phi inside. So I am getting integration 0 to pi by 2 d phi, outside r square sin theta upon 1 plus r square whole square into dr d theta. So what is the integration of d phi? It is a phi, upper limit pi by 2, lower limit 0. So directly also you can find it is a pi by 2. So phi, lower limit 0 to pi by 2. Here r square sin theta upon 1 plus r square whole square into dr d theta. So here upper limit minus lower limit. So I am getting pi by 2 and it is directly outside because it is a constant. So I am getting pi by 2 outside. So there I am taking directly pi by 2 outside, and note that now these are the limits of theta 0 to pi by 2. So only theta inside. So I am getting outside 0 to infinity and inside 0 to pi by 2, only theta inside. It means that sin theta d theta outside r square upon 1 plus r square whole square to dr. So what is the integration of sin theta? It is a minus cos theta. So I am getting minus cos theta, lower limit 0, upper limit pi by 2, and remaining as it is. So I equal to pi by 2 integration 0 to infinity. Here cos pi by 2 is 0 and lower limit 0. So cos 0 is 1, but minus minus plus 1 and remaining as it is. So r square upon 1 plus r square whole square dr as it is. So finally I am getting I equal to pi by 2, it is into 1, this one, and integration 0 to infinity r square upon 1 plus r square whole square into dr. Note that here you have to use second definition of beta. So how? So put r square equal to t, then r equal to root t, and dr equal to 1 by 2 root t into dt. What about the limits from r to t? Given limits 0 to infinity, t also 0 to infinity, because here if we put 0 we will get t equal to 0 and infinity we will get t equal to infinity, and that is why I equal to pi by 2 integration 0 to infinity r square is a t upon 1 plus t whole square into dr. Dr is 1 by 2 root t dt. Which formula I am using? Note that we should know beta of mn, second definition, that is a 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx. So by using this definition, it is very clear that, so what is the power of t? So I equal to this 2 outside, so I am getting pi by 2 into 1 by 2. This is a pi by 4 integration 0 to infinity t raised to half, because here 1 and this will be minus half. So 1 minus half, only half, upon 1 plus t whole square dt. So by using this definition, note that first is what? Whatever the power plus 1 and addition of this should be here. And that is why I am getting I equal to pi by 4, here beta of 1 by 2 plus 1, it is a 3 by 2. And what is the 2 minus 3 by 2? It is 1 by 2. So by relation between beta and gamma, I can find this value. It is a gamma separation upon gamma addition. So gamma 3 by 2, gamma 1 by 2 upon gamma addition 3 by 2 plus 1 by 2. It is a gamma 2. And that is equal to pi by 4. So gamma 3 by 2, it is a 1 by 2 root pi. Gamma half it root pi upon gamma 2 is 1 factorial means 1. So I am getting here pi, here pi square by 8, which is your required answer.